Have you ever seen Formula One pit stop where the tires are being changed? In 1950s, it used to take more than 60 seconds, but now it is less than 2 minutes. It means by the time I have spoken this line, many tires have changed. Now think about a factory scenario when there's a die changeover. Imagine that if the die changeover happens so quickly. But in a normal setup, in a typical company, what happens? When one product line stops, no one knows that what is the next plan. So a lot of time is going there. Then no one knows that where the die is there, it has to be changed. Then when it is decided that okay, this is the die that needs to be placed, then we are waiting for the crane because crane is busy somewhere else. And then maybe there is a possibility that we don't know where the material is kept, or maybe the material is not preheated, and there can be so many things which is possible. Now imagine that in case we are using SMED, single minute exchange of die, which talks about the two key concepts, internal system and the external system. When we talk about internal system, it means all those things which are going to happen on the machine. When we talk about external setup, it means all those things which should happen parallelly and there is no need to wait for anyone on that. And to explain to that about SMED, single minute exchange of time, exchange of dies, let's take one example of a molding machine where there is one particular tool having maybe the blue color of material which is there, and now we are changing to the red color of material. And assume that there are 10 key steps, and the first step is to observe. When we talk about observing, the main intent is that we need to observe it by using our videography so that we can know each and every step what is there. So if there are 10 key steps, let's identify that which are the steps which are internal and which are the steps which can be external. So the first or the few steps which can be internal is about the machine cool down or the mold changeover from that, or maybe the putting of the new mold into that, and certain other things with respect to the process parameters. But there will be certain things which can be external, but we are doing it sequentially. So for example, there are certain things which can be identified like this, is that maybe we are using or waiting for the material, that whether it is there or not, we are waiting for the mold, maybe we are waiting for the crane, and there can be many things which are happening there. And if we list all the things, if you are doing it sequentially in a typical company, maybe it is taking 3 to 4 hours in that. Now let's talk about the step number 2. Now the step number 2 is primarily talking with respect to separating the internal and the external processes. Now as I was talking about certain things which has to be done externally, what it can be, maybe the first is to fetch the new mold. Maybe rather than waiting for the crane is available there. Then there can be some other external things. It can be with respect to arranging the raw material, or maybe setting up the process parameters. So for all those things, we don't need the machine. But all the other things like the machine cool down, mold cool down, setting up the process, new parameters, and all other things, that we have to do it internally. Once we identify the internal and the external, then the third step comes. When we talk about the third step, it is talking with respect to conversion, that how we can convert internal to external. When we talk about converting internal to external, then what are the steps that we discussed? It was all about mold, about raw material, about crane, and setting up the process parameters. Once we do that, then we identify that we saved more than 1 hour there. Then comes the last step, the step number 4, which is talking about streamlining it. Now there are so many processes which are being internally, which we have to do. What we can do with respect to that? Can we reduce the time there? So let's talk a little bit about that. So what we can do in the internal task. So maybe we can use quick release clamps instead of bolts. That can save a lot of time. We can also use standardized mold heights. Instead of putting up shims every time to adjust, we can use some standard molds. Then rather than having one operator in sequence, we can use maybe 2 operators, and they can work in tandem each other to see that how the changeover can be done. And then apart from that, whatever is the preset trial run parameters, we can identify what happened in the last time, and then we can set up all that. Once we do all those things, there is a high possibility that from 3 to 4 hours, the time will go down to a couple of minutes, maybe 10 to 15 minutes. And why it is happening? It is just happening because we identified all those activities which we can do in parallel, and whatever activities that we are doing it, rather than doing some in a traditional way, we can find some better ways to effectively implement that. So in a way, when we talk about the key takeaways, we are talking about how we can streamline, how we can minimize the time, how we can make sure that we can use certain external things separately so that we don't need to wait for that. There's a very important line which is being said with respect to SMD, that operator should wait for the machine and machine should never wait for the operator. Now, often it has been seen that many companies have implemented all these good practices of SMED, but still after a while, they have not been able to continue that. What can be the possible reason for that? The first and the foremost reason is that many a times the operators who are actually working on the machine, they are not being involved in this entire process of SMED. Secondly, often it is being seen that we are not properly documenting each and everything, that how that process has to be done, and the training is not there. Moreover, it is also being seen that in many companies, we don't think that videography is important. And when we are not doing it from the last OK piece to the first OK piece, we don't realize there are certain things in between which we are missing it. And then certainly many a times we are considering SMED as just a single time event wherein we just want to justify that yes, we have done that. Now, talking about the good or the benefits which the organization can get, the first and the foremost benefit is with respect to OEE, overall equipment effectiveness, which talks about three things: availability, quantity, and the quality. So obviously, when rather than 3 to 4 hours, we are changing over the mold in say a couple of minutes, so we are having that much of time, that much time is available. When the time is available, automatically we can produce that much of quantity of material. And then if we are doing it systematically and effectively, we can also ensure that the quality of product is good. Then apart from that, the employee morale improves because they can see that yes, they did something valuable for the company and they have a good satisfaction about that. Then apart from that, overall, when we talk about just in time, it helps in that, and we can also reduce the inventory because we are having smaller and frequent production runs, which helps the organization to do the things in a better way. So in a way, when we conclude it, we can summarize it in one line that SMED is not just a tool, it's a mindset shift, because the SMED fails when it is treated as a one-time event and it succeeds when it becomes a way of thinking. To talk about some of the key industry challenges, the most and the common challenges with respect to change. We always have a resistance to change, that why should I do it? If we see from the perspective of operator, the operator feels that now his skills will not be considered that important. Maybe the supervisor thinks that he had some control over the entire process, but now that is gone. If we talk with respect to the management, it required some initial investment, but the focus is primarily on the production, so they are not very much focused that they can get a benefit in the long term, so they are just looking for a short term benefit. And because of that, what happens that we continue to do the same thing, and even if we do it one time, it just remains a one time event. The very important punchline which I would like to share here is that the hardest part of SMED is not the stopwatch, it is the mindset. So if I do a summary, I talked about SMED, I talked about the two steps, internal setup and external setup. Then I talked about the 4 key steps which can be done to ensure that how we can identify the thing which can be done externally, and then we can reduce the overall time. Then I also talk about the key pitfalls which are there, which generally does not make sure that SMED is effectively implemented. And in the last, I talked about the key industry challenges. My next video will again be in the same line, where I'm going to talk about the tap time. Regularly, I'm getting a lot of feedback from your side, and they're helping me to understand your expectations. So please do continue that. In case you want to understand a little bit more about this video, you'll find a link below. If you click that, you'll find a blog there, and there you can find more information about this video. In case you're liking these kind of blogs and videos, you can always share with your friends and colleagues, and you can subscribe to my YouTube channel and my website bhavyamangla.com. Recently, I have published a book related to supply chain management. In case you want to know more about it, you'll find a link below. You can click that and find more information. Thank you.